Hello friends, this is lesson 12 and this lesson is all about solving word problems using area. So let's get right to it. Number 1 says each side on a sticky note measures 9 centimeters. What is the area of the sticky note? So if I draw a little sticky note, this is 9 centimeters and this is 9 centimeters. So to find that area, okay, capital A equals the side times the length. And 9 times 9 is 81. So we've got 81 square centimeters. And that's all you need to know for area. All right, let's go to number 2. Stacy tiles the rectangle below using her square pattern block. So that just means she's making squares. So the area is what we need to do. And let's just read part A first. Find the area of Stacy's rectangle in square units. Then draw and label a different rectangle with whole number side lengths that has the same area. All right. So we need to count the side lengths. We got 1, 2, 3. So this is 3 units. And this is 1, 2, 3, 4 units. So to get the area, it equals 3, our rows, times the number in each row, which is 12 square units. Okay, so now we have to draw a different one that has 12 square units. Okay, that's the area, right? So we need to think of 2 different numbers that we can multiply together to get 12. And a lot of things come to mind for me, but 2 times 6 is usually the first one for some reason. So that means this side is 2 units, and this side is going to be 6 units. Okay, and I can either draw those lines in or not. So I'll draw them in just to prove it. Okay, so this is 1, 2, and this is 1, 2, 3, 4, 5, 6. So if I count by 2s, 2, 4, 6, 8, 10, 12. That accomplishes what I was asked to do for part A. Now, can you draw another rectangle with different whole number side lengths and have the same area? Yes. Okay, because there's other ways to make 12. What about 1 times 12? Right? I can do one long rectangle. This is 1 and this is 12. 1 unit, 12 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there are different ways to multiply to get 12. That's how I know. So I've got 3 times 4, 2 times 6, 1 times 12, and then if we turn all of these, we have the reverse. 4 times 3, 6 times 2, and 12 times 1. All right. Go to the next page. So now for number 3, I have an artist. An artist paints a 4 by 16 foot mural on a wall. What is the total area of the mural? Use the break apart and distribute strategy. Sounds familiar. So I've got a rectangle here. So it's 4 by 16, right? Well, we've got a 4 by 10 piece. Plus, I know this is 4, so it's 4 times 6. This is where we're breaking apart the big rectangle into 2 smaller ones. So 4 times 10 is 40, plus, well, this should be an x. 4 times 6. 4 times 6 is 24. That gives me 64, and I need my units, square feet. Notice these units do not have square by them because they are just this little line here that makes the edge, and this line here that makes the edge. When we talk about the area, though, we're talking about all the squares in there, like this picture. All right. Alana tiles the 3 figures below. She says, I'm making a pattern. All right. A. Find the area of Alana's three figures and explain her pattern. All right, so this is 2, and this side is 2. 2 times 2 is 4. This side is 3. This side is 3. 3 times 3 is 9. This side is 4, and this side is 4. 4 times 4 is 16. So we found the area, so how do you explain that pattern? Well, we can say that the two side lengths are the same in each pattern, or in each square. Really, they're squares. That is the kind of the definition of a square, right? Each side has the same length. Let's see, here we're adding 5. To get to here, we're adding 7. So there's not really a pattern going there. So I think we'll just have to explain the pattern as the side lengths being the same. Okay, so the side lengths for each square are the same, and just thought of another thing, they each increase or go up by 1, right? You have 2, then 3, then 4. All right, draw the next two figures in Alana's pattern and find their areas. All right, so if these two sides are 4, that means this one has to be 5. And this one has to be 6. All right, so I'm not going to draw all these lines in here because I can multiply. What's 5 times 5? 25, right? And 6 times 6 is 36. All right, so I've drawn the next two and found their areas. All right. Oh, and that's it for number 4. All right, last one, number 5. Jerry glued 3 identical pieces of paper as shown below and makes a square. So this is like 1 piece, 2 pieces, 3 pieces. Find the unknown side length of 1 piece of paper. So here's our unknown right here. Find the total area of 1 piece of paper. All right, so what do we know? We know this is 9 and this is 9. So if I have to break this 9 into 3 equal pieces, that's the same as doing 9 divided by 3 equals n. So what times 3 is 3? Excuse me, what times 3 is 9? 3. Okay, so each one of these sides has to be 3, right? 3, 6, 9. So since this side is 3, that means this side is 3. So we've found the unknown side length. Now we have to find the total area of 1 piece of paper. So we can multiply the sides. 3 times 9 equals y. So what is equal to y? 3 times 9, that's 27. So I'm just going to write that in a sentence. The area of 1 piece is 27 square centimeters, and the length of one side is 3 centimeters. Okay, notice again with my labels, when I'm talking about the area, I'm talking about the squares, but when I'm talking just about the measurement of a side, it's not a square, it's that line. All right, go ahead and get started on your Lesson 12 homework.